Okay, welcome back to Mr. Hassan's Maths channel. In this video, I'm going to be answering question number 7 from the Solomon C P3 collection of papers, and this also corresponds to question number 4 from the end of topic worksheet that I give my students in P3. This is for the chapter 4, Trig addition formulae. So here we got to express 4 sine x plus 3 cosine x in the form r sine x plus alpha, where r is greater than 0 and alpha is between 0 and pi over 2. So when you've got to express this in the form of this compound angle, okay, then what you need to do is to use the compound angle formulae, or they're called the addition formulae. It's another word for them. And the one that relates to this is the one for which you're going to have to expand sine an angle plus another angle, which you find in your formula book as follows. You'll find this in your formula book: sine A plus minus B equals sine A cosine B plus minus cosine A sine B. So you have to apply this formula to this. So what we're going to do is we're going to set up an identity. So I say that 4 sine x plus 3 cosine x is going to be identical to r sine x plus alpha. And what I'm going to do now is I'm going to expand this using this pattern here. So remember, it doesn't expand as sine x plus sine alpha. No, it's not like some algebraic expression that sine is on it, like an x or a y or something that's doesn't mean sine times this bracket. That doesn't make sense. Sine by itself means nothing. It has to have an angle with it, and this is the angle. So to separate the x and the alpha, we use this pattern here. Okay, we don't need to go into the reasons why, we just need to know how to use this formula. So you have r times sine x. If you expand it, you see sine, the a is like your x and the b is like your alpha in this, if we apply it to this. So r times sine x times cosine alpha. Now there's a plus between them, so it says a plus and a plus. There must be a plus between them there. And you've got r times, and then you've got cosine a, which in our a is x, times the sine of b, which in our formula is alpha. So now I've got this identity. Okay, our objective is to find the value of alpha and r. That's an x there. Okay, with identities, you've got to compare the coefficients of whatever's on each side, because one side is identical to the other. So if this left side is identical to the right side, the coefficients of the variables will be the same. Now the variable on this side is sine x, and you have another variable which is cosine x. These are the two variables. So you have sine x and you have cosine x. Those are the variables. Okay, so if I compare the coefficients of sine x, on both sides, on the left side I have 4, and on the right side I have r times cosine alpha. So I know that 4 must be the same as r cosine alpha, because the number of sine x's must be the same. And if I compare the coefficients of cosine x on both sides, on the left side I have 3, and on the right side I have r sine alpha. Okay, from here there's lots of different ways you can proceed. I personally prefer this method where I say, okay, I make cosine alpha the subject, so cosine alpha equals 4 over r, and make sine alpha the subject, so sine alpha equals 3 over r, and just make a little right angle triangle with an alpha, and then a little right angle triangle, and you have an alpha there. So you have an angle alpha here, and cosine alpha is 4 over r, so this is the adjacent and this is the hypotenuse, and sine alpha is 3 over r, that's the opposite and that's the hypotenuse. So we can see very clearly that r is the hypotenuse of this right angle triangle, where you've got 3 and 4 as the two shorter sides. So we can see that r is equal to 5 by Pythagoras. if you want to just show your steps, r equals 3 squared plus 4 squared rooted, which is 5. So I know that r is equal to 5. So now, in this, we know that this part is 5. Now we've got to find what alpha is, which is pretty simple because you can just use, for example, tangent. You can say the tangent of alpha is equal to the opposite, which is 3, over the adjacent, which is 4. So alpha is equal to inverse tan of 3/4. Now, they want the answer here in radians. So you have to make sure that your calculator is in radian mode. Now, my calculator here is in degree mode, so I have to change it to radian mode first. So angle unit 2 is radians. Now it's in radian mode, and we can proceed. So let's inverse tan of 3/4, inverse tan of 3/4. And that gives us 0.6435. I'm going to store this as A in case I need it later on. So 0.6435, 0.6435. Now, how did they tell us to round the answer? Okay, they didn't tell us how to round the answer. Okay, so I'm going to leave it to 3 as F because that's the normal instruction. So I'm going to say that therefore our original statement, which is 4 times sine x plus 3 times cosine x is equal to r, which is 5 times the sine of x plus, and I'll write this as 0.644 to 3SF. So now I have expressed this in the form, okay, required in the question part A, and now we can move on to part B. Okay, part B, it tells us to state the minimum value of 4 sine x plus 3 cosine x and the smallest positive value of x for which this minimum value occurs. So you have 4 sine x plus 3 cosine x is equal to 5 times the sine of x plus 0.644. Okay, so now, once we've expressed it like this, it's very easy to see what the maximum value is going to be of it, because we know that sine x plus 0.644, the maximum value of the sine of any angle is going to be 1. So the maximum value of this is going to be 1. Therefore, the maximum value, okay, of 4 sine x plus 3 cosine x is going to be 5, because this is going to be 5 times the sine of an angle. The sine of an angle, the maximum, it can be 1, the minimum, it can be -1. They're asking us for the minimum, so they're asking for the minimum. Read the question. So the minimum value can be -1 of this. Okay, therefore the minimum value of our expression is going to be -5. Alright, so of course we should read the question. So the minimum of this value, this is going to be -1, so the minimum of the whole expression is going to be -5. Okay, 5 times -1. 5 times -1, which is -5. Then it says, and the smallest positive value of x for which this minimum value occurs. So we can see that the minimum occurs when the sine of x plus 0.644 is equal to -1. Okay, that's when the minimum is going to occur, when this part becomes -1. So we have to just solve this equation. So to find the value, you're going to do x plus 0.644 is equal to inverse sine of -1. Okay, now the inverse sine of -1, the calculator will give you pi over negative pi over 2. Let's just make sure of that. Inverse sine of -1. The calculator gives you negative pi over 2. Okay, negative pi over 2. Now, if I accept this value, and then I have to find what x is, I'm going to get something that's negative, and they want the smallest positive value of x. So I've got to think about the next place where inverse sine equals -1. Okay, with the next angle where the sine of the angle is -1, but on the positive side, and that's going to be 180 or pi minus this. So it's going to be pi minus the answer. So I know that's going to be 3 pi over 2, but we'll just show you. So pi minus the answer is going to give you 3 pi over 2. So the next place on the positive side where the sine curve hits -1 is at 3 pi over 2. Now this will give us hopefully our answer, because we can say x is equal to 3 pi over 2, and we've got to take away 0.644 from this. So the value of x is going to be this minus the answer that we had before. I'll just give it in its exact form. It was 0.643, that one, so that's recall A. So answer minus A is going to give us 4.0688. 4.0688. Now let's round that to how we have to round it. Okay, they didn't mention anything, so I'm going to put 3SF. So that's going to be 4.07. That is the smallest positive value of x where this will reach its minimum value. Okay, so there's the answer to part B. Now, we're going to answer part C on the other page. Okay, now here we have question part C. I've just written down the result for part A and B because this will help us solving in part C normally. Normally it's got something to do with the previous questions. So it says solve the equation 4 sine 2 theta plus 3 cosine 2 theta equals 2. So we can see the link between this and the previous question. So we can see that this is 4 sine 2 theta plus 3 cosine 2 theta, and this is 4 sine of an x plus 3 cosine of an x. So these basically, have the same kind of pattern. All right. So if 4 sine x plus 3 cosine x is 5 sine x plus 0.644, then 4 sine 2 theta plus 3 cosine 2 theta will give us 5 times sine 2 theta plus 0.644, because they're the same pattern. Okay, so basically what we can do here is we can say, therefore 4 sine 2 theta plus 3 cosine 2 theta will be 5 times the sine of 2 theta plus 0.644. So now we can say that we can make this equal to, so therefore this is equal to 2. So we can now say that 5 times the sine of 2 theta plus 0.644 must be equal to 2. So we can say the sine of 2 theta plus 0.644 is equal to 2 over 5. Okay, now we can find the inverse sine of 2/5 and we can solve the problem. So let's find the inverse sine of 2/5. So we have 2 theta plus 0.644 equals the inverse sine of 2/5. Okay, and again, of course, we have to be in radian mode here. Okay, from 0 to pi, we have to solve it. So first of all, now what we have to also do is we have to modify the range. Now the range is given up to pi and it's in terms of theta. We have to change it to the same thing that we got, which is 2 theta plus 0.644. So we have to catch all the angles in the range. So this center part here has to say 2 theta plus 0.644. Let me give myself some more space. Okay, so we have to change the range. So it says 2 theta plus 0.644. So at the moment it's got 0 is less than or equal to theta, less than or equal to pi. We have to change it. So the middle part says 2 theta plus 0.644. So I have to basically multiply 0 by 2 and add 0.644. So my answers have to start from 0.644 and they end, and I have to multiply by 2 pi by 2 and then add 0.644. So let me just do that. So I've got my answer here, 0.644, okay, times 2, sorry, plus 2 times pi, 2 times pi, yeah. That gives us a 6.927. So 6.927. So I know that I have to get all the angles within this range, starting from there to there, and then that will give me the solutions in the range required. So first, as I said, I have to find inverse sine of 2/5. So that means 2 theta plus 0.644 is equal to inverse sine of 2/5. So that's the first thing I have to do. Inverse sine of 2/5. Let's see what that gives us. Okay, that gives us 0.4115. Okay, so 0.4115, 0.4115. Now that's an answer which I'm not going to actually accept because it's out of my range. Okay, and when I adjust my answer according to this, it will be out of the original range. It will give you a negative answer. You can see that. So I'm not going to accept that as my final answer, but I'm going to keep it written down to help me generate the other solutions. Because for the sine curve, to find the other angle that is within the range, you're going to do pi minus this. So I'm going to do pi minus this answer. So I'm just going to store this answer as B in case I need it again. But I'm going to do pi minus the answer. So pi minus that answer is going to give me 2.7300 or 2.7301. I'll write 2.7301. Okay, that angle is in our range between here and here. So I'm going to accept that answer. Now I'm going to generate other solutions within the range. To generate other solutions in the range, I'm going to add 2 pi to these angles. So the angle I've got now, I'm going to add 2 pi to it and see what I get. So plus 2 pi, because it repeats every 2 pi. Now that's out of the range, so I'm not going to accept that one. Okay, however, we have the answer stored as B of the first angle, which is 0.4115. If I add 2 pi to this, let's see if we're going to be inside the range. And I assume we are. 6.694, yes. So you got 6.6947. So 6.6947, 6.6947. We can see that's within the range. 6.69 is in the range. So we have these two as our answers that are in the range. So now we have to adjust them to make them in terms of theta. So I have basically the answers I'm going to accept. So we've got 2 theta plus 0.644 equals 2.7301 and 6.6947. Okay, so now I have to subtract 0.644 and divide by 2. So theta is going to be, let me just make some space. Theta is going to be 2.7301 minus 0.644 divided by 2, and also 6.6947 minus 0.644 divided by 2, and I have my two answers then. Okay, see, what do I have in my calculator right now? Okay, I have this one, so I'll use this. So this minus the answer for A, what's stored as A, that's right. Okay, and divided by 2. And that gives us 3.0256. So that's 3.03 to 3SF. 3.03 is one answer, and the other answer is going to be given by this one, which is, let's see if I have part B is, that's not stored, so I'll just take it as this, 2.7301 minus what I've stored as A. Okay, and then that gives you that divided by 2, and you end up with 1.04. So 1.04 and 3.03 are the two answers to this question. Okay, those are the two angles within the range, okay, which solve that equation there. And there we have the answer to this question. So that's why, one of the reasons why they like to express something like this in the form. It's useful to express in this form so you can solve equations. And also for part B, you can kind of work out what the sketch will look like, what the maximum value will be, what the minimum value will be of that expression by just, making it in this form. Okay, so basically that helps you to sketch the curve if you do this, and it also helps you to solve equations involving involving this, which wouldn't be easy unless we change it to this form. So there we have the answer for this question, which is question number 7 from Solomon C, and question number 4 for my end of topic worksheet. Thank you for watching. Any questions that you find, all the questions from Solomon C that I've done, I'm going to put them in the playlist over here. So this is for P3 Solomon 3 paper, and any questions that you want to see from, Trig from P3 trigonometry, there will be a playlist over here you can click on. You can subscribe to my channel on the link over here, and I'll probably put on the card on the top some sort of past paper for P3 for you to watch. Thank you for watching, and I'll see you again soon.